Now here we will study the large memories. The organization of large memories by using the memory size 2 mega words of 32-bit each. Now if you take 2 mega uh, words with 32 bits, can also we can write it as 512 kilo with 8 bits into 16 number. So then both the size are same. So we will try to design the this organization of 2 mega 32 bit with a 512 kilo 8 512 by 8 memory chip. Now if you see here, this is a chip, memory chip. The size is 512 kilo by 8 memory. Here we need to write k. 512 kilo by 8 memory means what? Total 512 kilo. How can we write 512 kilo means what? 2 to the power of 9 into 2 to the power of 10 is equal to total 19 address bits are required. Now in each location, these are the number of locations are 512 kilo. In each location, 8 bits are stored. So this for this chip total 19 address bits are required and the chip select bit is there. Now why? Because here such chips we are using 16 number. So which chips are selected? Those chips. Now here we are, these are the select bits. Now these select bits are connected to this decoder. Now here total 16 chips are connected in a 4 rows. So now here to select any one of the row from these 4, we need 2 input bits. So to design this complete organize, now here we need the 19 address lines for to select the rows and address of this chip. Now in this chip, if I wanted to select a row and a column, then I need the 19 addresses lines. And similarly, now to select any one of the row here in this, I need 2 bits. Now that's why total I required 21 address lines to design the this large memory by using the 512K by 8 memory chip. Now here, if by using these higher order bits, now by placing 00, the first row will be selected. Now chip select bit means what? If it is 1, then these 4 will be selected. Now 01 means what? This 4 chips will be selected. 10 and 11 for last will be selected. Now like there, for example, if I say 00 means what? This row is selected. So total 4 512 kilo by 8 chips are enabled. Now again here in this needed to select a row and now by giving the address lines here. So depending upon that address lines, it will select the rows and columns. Now from that, it will place the 8 bits of information into on this the data bus. Now from this chip, 8 bits will be placed on this data bus, and from this chip, 8 bit will be placed on the data bus, depending upon these 19 address bits. How we are giving these 19 address bits? Again, these 19 address bits must be divided into rows and columns. Depending upon that, it will select the 8 bits. Now, total, if you see here, 4 8 bits are there, means what? Total 32 bits are generated. So after giving the 21 address bits, so it is giving the 32 data bits. Now this is the large memories that we can design by using the uh, chips, different chips. Now the next topic is memory system consideration. Now static RAMs are used to design the cache memories to increase the speed of the system, and DRAMs are used to design the main memory. Now here the speed is not considered, and by using DRAM, the density, it is having the high density. That's why we use these DRAMs to design the main memory. Now, if the processor want to read the data, it will place the address on the address bus and it will give the control signal. Now, this address, now to reduce the external pins, so this complete address should be, now here multiplexed address lines are used. Multiplex address lines are nothing but what? This complete address is divided into row address and column address. By dividing the address bus into rows into columns, the external pins can be reduced. That already we have studied in the asynchronous DRAM. Now this to divide the address into rows and column, we need one circuit. That circuit is called the memory controller, which is placed between the processor and memory. And after receiving the address from the processor, it will divide this address into row address and column address. And to select the row, it will the memory control unit will generate the RAS bar signal. And after selecting the row, the memory controller will give the CAS bar signal and read write to read the data and to write the data. Now processor is generating whatever the signal it is generating, the signal will be placed on this line. And here if you have seen in the previous topic, if large memories are there, now which chips should be selected, that can be done by using the chip select bit. Now here the processor is sending the clock and same clock is used, means what, these memories are designed by using the synchronous DRAMs, SD RAM. And after selecting the row and column, whatever the data is available, that is placed on the data bus. So now after placing the address and after giving the control signal, processor will send the request signal. So with this request, the memory control will respond and it will divide the address into row address and column address, and it will generate the RAS signal and CAS signal, and it will select the cells, and it will place the data on the data bus. Now, if these memories are, if SD RAMs, if these are not having the self, because these memories are designed by using the DRAMs, DRAMs are required the refreshing. So the capacitor should be charged because the capacitor is discharging periodically. That's why again this capacitor should be charged. So that can be done by the refreshing circuit. If this memory is not having, if this SDRAMs, this chip is not have, memories are not having the self refreshing circuit, then the memory controller should do the refreshing of the DRAMs. So after sending the RAS signal, row will be selected and that row is placed onto the latches. That time the memory controller will refresh the all the DRAMs in the memory. Now like that, the memory controller will take care of the refreshing also. Now the next topic is Rambus memory. Now already we have seen that the performance measure can be uh, calculated by using the two parameters. One is the data rate and another one is the bandwidth. So this bandwidth can be achieved by using the double DDR SD RAM. Means what? So this bandwidth can be increased by reading the data for the both the edges, for rising edge and for falling edge, for both the edges. If the data transfer is done, then the bandwidth is increased. Now how the data rate is increased? By increasing the bus data bus lines, but that is a very that increases the cost, so that is expensive. And also it is not possible, this should be done in the motherboard. So it is a design complexity will increase. That's why, so we follow the Rambus technology to improve the transfer rate. So Rambus technology means what? Now giving the, now generally for logic 0 is 0 volts and for logic 1 is 5 volts. Actually there is some range is there, but this is the ideal case. So 0 is 0 volts, 1 is supply volts, depending upon the technology. Again, what technology we are using. Now here I'm taking the TTL technology. So 5 volts I'm considering. Now instead of taking like this, now if it is changing from 0 to 1 and 1 to 0 means what? It has to change the voltage from 0 to 5 volts and from 5 volts to 0 volts. So here it takes to change from 0 to 5 volts, it takes for transition time will be more. So instead of that, some reference voltage is taken, and on this, the voltages for logical values, they represented by the swing values. Means what? Reference voltage 2 volts is taken, and for the swing above and below of this reference, 0.3 plus or minus 0.3 volts is considered. Means what? 2.3 volts is for the logic 1 and 1.7 volt is for the logic 0. Now here if you see the difference from the logic 0 to logic 1, it is less compared to the normal voltage levels. So if we apply this is nothing but what? Rambus technology. By using this, now from the 0 to 1 and 1 to 0, the transition time will be less compared to by using these signals. Now this technology is called the Rambus technology, and this type of signaling is generally known as a differential signaling. Now with this we finished the semiconductor RAM memories.